Okay, well now we're at the time of year in geometry where we're learning about area, volume, and surface area. And what's happening? You're getting a load of formulas thrown at you, one after the other, and you're basically being asked to memorize them. Hopefully when you see a problem, you come up with the right formula. But you know what? Exams are less often giving you the formulas and you really have to know them. No! The purpose of this video is to obtain an understanding of each one of these formulas. When you switch to volume, there's a third dimension that is added. Like if you go to a 3D movie, right? A regular movie, you look at a flat screen like this is, but right, it comes out at you, and that creates the third dimension. A volume means it holds something, where an area is just a flat surface. Now, let's graduate from area to three-dimensional figures, or volume. Wait. The flat rectangle has now become a three-dimensional figure. You can call it a box. It now has volume. It has a third dimension. And it can hold something, in this case, tissues. Three-dimensional figures come in two basic forms. You have something called a prism, which is not where they keep criminals, okay? It has to do with two bases. It has a base on top and a base on the bottom that's the same. And then you have three-dimensional figures that come to a point, and they are called pyramids. So to recap, a prism has two bases, and a pyramid has one base. Now let's talk about prisms. Let's take a rectangular prism or a box. A prism is named after the shape of its base. And the formula for volume for a rectangular prism is the area of the base, which again is length times width, but now you're multiplying that third dimension, which is the height. So it's length times width times height.
Enough said.
Think of a cube. It's all squares. So what does that mean? The length and the width and the height are all the same. So if there's a cube, yes, I'm trying to draw a cube. Wait a second. Yes, I think I did it, except for that. Ignore that, right? And one side is 6. The volume would literally be 6 times 6 times 6. And I know you've studied exponents. 6 cubed, which happens to be 216. Now, let's take this box. This is a rectangular prism. But let's say all the sides cave in and they come to a point and they become a pyramid. So you're looking at a rectangular pyramid and you're trying to find the volume of that shape. So if you could picture like the pyramids in Egypt, right? And let's say the base is a rectangle, or let's say it's a square, and all the sides are caving in on all four sides and it's coming to a point, right? Well, the volume is still the area of the base, which is still a four-sided base, so it's length times width. But now we need to somehow measure the height. Now I'm going to draw a two-dimensional thing here. Let's see if it gets the point across. Let's say this was a prism, and let's say these are sides that are caving in and they're coming to a point. Okay, so this is now your pyramid. Well, we lose the volume here and the volume here. In fact, we lose 2/3 of the volume, and this is only 1/3 of the original volume. So you had this straight box of a prism where the height just went straight up like this, and now all the heights are caving into a point. That's why the volume of a pyramid is 1/3 length times width times height. Now just to recap, the area of a flat circle lying flat on a desk or the ground is pi times the radius squared. Now when a circle becomes a three-dimensional figure, it can become something called a cylinder, kind of like this paper towel, right? Where again it holds things, right? And there's a volume to this as well. Now think about it. The volume of a cylinder is just like the volume of a prism we just showed you. It's the area of the base times how tall it is. This determines how much the three-dimensional figure can hold. So what's the area of the base? Oh, it's pi r squared, and just multiply it by its height. The cylinder is like a prism in that it has two bases, right? A circle on top and a circle on the bottom. Well, what if that circle and the sides don't go straight up, but they come to a point? Now, if it was a rectangle or a square or a triangle, we'd call that a pyramid. But do you guys know when a circle comes to a point? I'll give you a hint, it's one of our favorite desserts. That's right, it's a cone, an ice cream cone. So the volume of a cone is the same idea. Instead of the sides going straight up, they're coming to a point and you lose 2/3 of the volume. So the formula for the volume of a cone is simply 1/3 pi r squared times the height. If any of you are struggling with this or any other concepts, please don't hesitate. Go to www.creativetutoringllc.com for more information.